guys, welcome back to my channel. I have already posted 4 videos on chapter 1 revision, chapter 1 of class 11th CBSE final exam preparation. And these videos are also important for your JEE and NEET revision of NCERT concepts. Today I'm going to take up concentration terms, the last video related to this particular chapter, and I hope it really helps. Please stay tuned, keep learning, keep working hard. And like, share, and subscribe, and do comment if this is helping or if you need any kind of changes in the videos coming next. Let us start. So we're going to talk of concentration terms, and please remember concentration terms are applicable to solutions. Solutions where the two components that we have are the solute and the solvent. The solute and solvent together make a solution. And we are going to discuss various concentration terms using number of moles of solute solvent or their masses or their volumes. So different ways of expressing concentration terms depending upon what kind of solution we have. If we are dealing with let us say a solid in solid kind of solution, then we would need concentration terms like percentage weight by weight. If we are talking about something like solid in liquid kind of solution, we might be using a concentration term like percentage weight by volume, or maybe we need to use strength, which is describing the weight of solute in per liter of solution, right? And in case we are talking about liquid in liquid, we could use a concentration term like percentage volume by volume. And similarly, for different kinds of solutions, we have various concentration terms. We are going to start with the first one, that is uh, describing the various kinds of concentration terms that we're going to deal. We will be talking about the first one, mass percent or weight percent, volume percent, mole fraction, molarity, and molality. These are the main concentration terms which are included in your uh, chapter 1 class 11th NCERT textbook. So I'm going to deal with each of these very quickly one by one, helping you recall. The first one is mass percent or and mole fraction. So when it comes to mass percent, just remember percent means per 100. So mass of solute upon mass of solution into 100 is mass percent. Similarly, volume percent is going to be volume of solute upon volume of solution into 100. But if we want to describe, say, a solution of a solid in liquid, we would need something like mass per volume percent, weight by volume percent, which will be described as mass of solute in gram upon volume of solution in ml. Now, a point of importance that you must keep in mind is, in this case, we can take mass of solute in gram, mass of solution also in gram, or I might take this in kg and this also in kg. Basically, any unit can be taken, but it has to be same unit for solute and solution, right? Similarly, when we are talking about volume, I could take here ml and here also ml, or I can take here liter and here also liter. It is important to take the same unit in the numerator and denominator. But when we are talking about mass by volume percent, we have to have equivalent units here. Equivalent means if I'm taking gram, which is the CGS unit, I need to take here also the CGS unit. So what is the CGS unit of volume? It is centimeter cube. And centimeter cube we discussed in the first video of this series. 1 centimeter cube is the same thing as 1 ml, right? So if you're taking mass of solute in gram, the volume of solution has to be in ml, and then we are going to simply multiply this with 100, because percent means per 100 parts. So as an example, if I'm taking, this is the NCERT in-text question, a solution is prepared by adding 2 gram of a substance to 18 gram of water. So very important to understand, weight of solute is 2 gram and weight of solvent, that is just water, is 18 gram. Hence weight of solution is going to be 2 plus 18, that is 20 gram. And now we are going to just substitute the values, mass of A upon mass of solution into 100, which means it's going to be 2 upon 20 into 100. So our answer will come out to be 10%. Next, we take an application. Mole fraction. A mole fraction is ratio of number of moles of a particular component to the total number of moles of all the components in solution. If a substance A dissolves in B, number of moles of A are Na, that of B are Nb, then what is mole fraction of each? Mole fraction of component A. Mole fraction of component A, I can express it using symbol chi A. So chi A can be equal to Na upon Na plus Nb, number of moles of one component upon total number of moles of the other component. Similarly, if I wanted chi B, it would be number of moles of B upon number of moles of A plus number of moles of B. And you understand, in a binary solution, binary means a two component solution, the mole fraction of both the components will be equal to 1. Clear? Why? You can just check it from here. When you add this term with this term, the denominator is the same. The numerator also becomes Na plus Nb. So the sum total of mole fractions of the two components will become equal to 1. Fine. Remember, mole fraction has no units, or in other set of words, you can be asked mole fraction is a dimensionless term. Mole fraction is dimensionless. It has no units. Sum of mole fractions of all components is equal to 1 for every kind of solution, even if it's a ternary solution. Ternary solution means if you have Na, Nb, Nc to be the number of moles of three components, it's a three-component solution. Chi A will be equal to Na upon Na plus Nb plus Nc. Similarly, chi B is going to be Nb upon sum total of these three, and chi C is going to be Nc upon sum total of these three, such that chi A plus chi B plus chi C should be equal to 1. So just remember, sum of mole fractions of all the components is equal to 1, whether it's a binary, ternary, or any type of solution. Next is mole percent is equal to mole fraction into 100. Basically, mole fraction is per 1, per unit. For if we consider total to be 1. For example, if total number of moles are 1 and number of moles of A are 0.2, then number of moles of B will be 0.8. Fine. So what will be mole fraction of A? It will be 0.2 upon 0.2 plus 0.8. That is 0.2 upon 1, that is 0.2. Right? And if the total number of moles are considered as 100, the number of moles of A, let us say, are 20 and number of moles of B is 80. Then what is chi A? It is going to be 20 upon 100, again 0.2. So just remember, mole fraction when multiplied by 100 gives us mole percent. Clear? So if I say the mole fraction of a component is 0.2, then its mole percent is going to be 0.2 into 100, that is 20, which means out of a total of 100 moles, moles of A are 20. And mole fraction equal to 0.2 means out of a total of 1, the number of moles of component A are 0.2. So mole fraction is part of a whole. That means if we are assuming the total to be 1, then we express it as mole fraction. If we assume the total to be 100, we express it as mole percent. So if we take 44 gram of carbon dioxide and 14 gram of nitrogen, what will be mole fraction of carbon dioxide in the mixture? So weights are given and you are asked to calculate mole fraction. What are we going to do? We are going to convert number of the given weight of carbon dioxide to number of moles. That's going to be 44 upon 44. That's 1. Similarly, we'll convert the given weight of nitrogen to number of moles. That's going to be 14 upon 28. That's half. And now mole fraction of carbon dioxide is going to be number of moles of carbon dioxide plus this is total number of moles. This component is total number of moles, NT. Mole fraction of carbon dioxide is going to be number of moles of carbon dioxide upon total moles. That is 1 upon 1.5. We get it as 3 by 2. Right? So this is how we calculate mole fraction. Let us suppose in this question only, if I had asked you to give the mass fraction, let us suppose I had asked you percentage weight by weight in this. What would you have done? Percentage weight by weight of, let us suppose, nitrogen. So what would I do? I would do 14 upon 44 plus 14 and then into 100. 14 is the weight of nitrogen upon total weight of carbon dioxide plus nitrogen into 100. This is going to be percent strength weight by weight. But if I'm asking mole fraction, I'll have to convert it to number of moles of what is asked upon total number of moles of both. And supposing in this same question, you were asked to give mole percent, then what would you do? 3 upon 2. You will take this 3 upon 2 and multiply it with 100. This is going to be mole percent. Mole fraction into 100 is mole percent. I hope these terms are clear. So we move on to the next one, molarity. Next concentration term is molarity. It is the most widely used term and most common for exams also. It is defined as the number of moles of solute present in 1 liter of solution. An important point to keep in mind, it is 1 liter of solution, not solvent. So molarity is defined as number of moles of solute upon volume of solution in liter, or it could be in case number of moles are given and volume is given in ml. To convert this volume into liter, we will be multiplying it with 1000. And also if number of moles are not given but weight is given, you know it's going to be weight upon gram molecular weight into vml into 1000. This becomes the calculation for molarity. Now, if W gram of a solute is present in VML solution, so we are going to calculate it as W upon molecular weight into 1000 upon VML. And this is the description of each of the terms. Right, this is recalling the formula. Other important formulas that we use in this is molarity is equal to 10 into percent weight by volume of solution upon gram molecular weight. So if you are given, let us suppose you are given a 10% weight by volume solution of urea, right? Molecular weight of urea is 60. If this is given and you are asked molarity, what are you going to do? Very simple. This information means 10 gram urea is present in 100 ml solution. Why? Percent means per 100 parts. You want molarity, weight of solute upon molecular weight of solute. Here I'm going to put VML and here 1000. This will cancel off and give us 10. So what is the formula? This 10 is this 10. Then this percent weight by volume is this percent weight by volume. And then this gram molecular mass is this gram molecular mass. Clear? So this is how we do the application. Percent weight by volume into 10 upon gram molecular mass. Clear? Now, second formula is that we use is 10 into density into percent weight by volume of solution upon gram molecular weight. We sometimes also learn it as X D 10 upon molecular weight, where X specifically is percent weight by weight. Remember in this formula it was percent weight by volume. Here it is percent weight by weight. And hence we are going to include the term density, where this density has to be in gram per cc. This is 10 and this is molecular weight. I again take an example here. Supposing I give you, I have 10% weight by weight solution of urea. Okay, and I give you the density to be, let us say, 1.2 gram per cc. And I ask you to calculate molarity this time. So what am I going to do? This time, this information tells me 10 gram urea is present in 100 gram solution. So since it's given to me as 100 gram solution, what do I need? I need volume of solution to calculate molarity. And I know density is weight upon volume. So volume is going to be W upon D. From this formula, volume is going to be weight upon density. Right? So weight of solute here, weight of solution is going to be 100 gram. Why? I want volume of solution. I'm going to take weight of solution and divide it with density of solution. This is going to be volume of solution in which unit? This is gram per ml. Isn't it? Gram per ml. So ml will go in the numerator. Gram cancels off. I get volume of solution as 100 upon 1.2 ml. And now when we have to calculate molarity, it is weight of solute upon molecular weight. This makes moles. I want V ml. So 100 upon 1.2 means I take 1.2 in the numerator. And since this was in volume was in ml, I multiply it with 1000. I repeat, children, this is moles. Then this much part is VML. And to convert VML to liter, I multiply it with 1000. So when I solve this, this 100 goes with 10. What am I left with? I'm left with 10 into 1.2 into 10 upon 60. Where if I look into the description, this 10 is the percentage weight by weight. This 1.2 is the density. This 10 is this 10, right? And this molecular weight is this molecular weight. That's the application of this formula. I hope this is clear. Use the overall formula only when you have practiced it well in your practice sessions. Otherwise, do it by understanding. Then the next is the dilution formula, the dilution law. M1V1 is equal to M2V2. Where are we going to use this? We have two important kind of questions under this. Let us suppose I tell you I have 100 ml 0.1 molar HCl solution. And I ask you, what is the new volume of solution to dilute it to 0.03 molar. 0.03 molar is lesser concentration than 0.1 molar. I'm going to use M1V1 is equal to M2V2, where M1V1 is the original molarity, original volume. This is the new molarity and new volume. I just solve it. I get total V is 10 upon 0.03. 100 into 0.1 is 10. I divide it with 0.03. I get 1000 upon 3. That is 333.3 ml. Clear? Now, in this same question, if I had asked you, same question, calculate the volume of water that needs to be added. that needs to be added to convert 100 ml 0.1 molar to 0.03 molar. Please understand, this is calculate volume of water that needs to be added. This was new volume of solution. So new volume of solution is 333.3 ml. The new volume is 333.3 ml. Original volume of solution was 100 ml, right? So what is the volume of water that needs to be added? The volume of water that needs to be added is 233.3 ml. Please note this difference. Only two types of questions are generally asked at the school level. Either new volume of solution, which is going to be this, and to make this volume of solution, we are going to add this much more water into this solution so that the new concentration becomes 0.03 molar. We move on to the next formula. The next formula is neutralization reaction, where we are going to use M1V1 upon N1 is equal to M2V2 upon M2. Now, where do we use this formula? This formula is to be used for complete reaction. For example, I ask you, calculate volume of 0.2 molar sulfuric acid required to completely neutralize 100 ml 0.03 molar sodium hydroxide solution. Okay, so what is the reaction? Sulfuric acid reacts with sodium hydroxide to give Na2SO4 plus 2 water. This stoichiometric coefficient, this is 1 and this is 2, is what is written here. Okay, so if I'm taking this as sulfuric acid, then this N1 is going to be 1. If this is sodium hydroxide, N2 is going to be 2. Why? This is the stoichiometric coefficient in the balanced chemical equation. So what am I going to do? I'm going to put M1 as 0.2. That is molarity of sulfuric acid. Volume is what I need to calculate. N1 is 1. For sodium hydroxide, it is 0.03 into 100 upon the number of moles of sodium hydroxide are 2. I put 2 here. So V1 is going to be 3 upon 0.4. Solve it 30 upon 4 and you get your answer. And this answer will be in ml. Okay. So this is the dilution equation. Now this same question could also be done by the use of the formula N1 M1 V1 is equal to N2 M2 V2. Same question if I ask you calculate volume of 0.1 molar sulfuric acid required to completely neutralize 100 ml 0.03 molar sodium hydroxide. Same question. I can also use this formula. Now this formula works in what way? This is sulfuric acid. This is sodium hydroxide. This is going to be the N factor. When we put this N1 in the numerator, this means N factor. What is N factor of sulfuric acid? 2. For sulfuric acid, it is 2. For sodium hydroxide, it is 1. Why? Sulfuric acid has 2 ionizable hydrogens. So its N factor is 2. Sodium hydroxide has only one OH. Its N factor is 1. So what am I going to do for sulfuric acid? It's 2. The molarity is 0.1. Volume is what I need to calculate. This is 1. N factor of sodium hydroxide is 1. Its molarity is 0.03 and its volume is 100. So I'm going to calculate V as 3 upon 0.2. I'm going to again get 3 upon 30 upon 2. That is 15 ml. Right? N factor. If you're using this formula, this N stands for N factor. If you're using this formula, this stands for the stoichiometric coefficient in the balanced equation. I hope this is clear. The next is to find out molarity of a mixture of two similar solutions. Now, to make you understand this concept, let us suppose I have 100 ml 0.1 molar HCl mixed with 200 ml 0.3 molar HCl. And I ask you the total H plus ion concentration. Fine. So what am I going to do? M1 V1 plus M2 V2 upon V1 plus V2. This is going to be the overall concentration. So solve it. 10 plus 60 upon 300. So 70 upon 300 will be the molarity. So this is the basic application of the different formulas that we use under molarity. Molarity of a solution depends upon temperature. Why? Because volume of a solution is temperature dependent. In general, children, remember, any concentration term which will have volume in it will be temperature dependent. Its concentration will change with temperature. Why? Because volume changes with temperature. Let us take up the first NCERT problem. Calculate molarity of sodium hydroxide, the simplest one, in the solution prepared by dissolving 4 gram in enough water to form 250 ml of solution. Please remember, 250 ml is not the volume of water added, it's the volume of solution, resulting solution. So we are simply going to apply the formula. Number of moles. How do we calculate number of moles? 4 gram upon 40. And then enough water to form 250 ml solution means 0.25 liter solution. The answer is 0.4 molar. If you want to substitute it this way, you can do it this way also. Weight of sodium hydroxide is 4, molecular mass 40, V ml is 250 into 1000. 0.4 molar is the answer. I hope this is clear. This is the most basic type of molarity question. Okay, now this is NCERT exercise question number 1.35. It says calcium carbonate reacts with HCl to give calcium chloride, carbon dioxide in water. What mass of calcium carbonate is required to react completely with 25 ml of 0.75 molar HCl? Right? So what are you going to do here? You can first calculate the number of moles present. So you know the formula for molarity is given weight upon 36.5 upon given weight upon 36.5, here V ml and 1000. So 0.75 gram, sorry, this is molarity. From here, I take out the formula for W. So W is going to be what? W is going to be molarity into 36.5 into V ml upon 1000. Right? So weight of HCl is going to be molarity 0.75, 36.5 ml, VML is 25 and 1000, and we get this weight of HCl. Or we could have done it like this. Molarity is equal to number of moles of HCl upon VML into 1000. Right? And we know molarity is 0.75. So 0.75 into 25 upon 1000 would be equal to number of moles of HCl. Instead of calculating the weight, I could have calculated the number of moles. Fine, any of the two ways we could go proceed. So once we get the number of moles of HCl, we know for every 2 moles of HCl, only 1 mole of calcium carbonate is required. 2 moles of HCl means for 73 grams of HCl, we require 1 mole of calcium carbonate. So this weight of HCl, 0.6844, will react completely with this much of calcium carbonate. You could have done it in terms of moles also, calculate the moles of HCl, and you know for every 2 moles, you need 1 mole of calcium carbonate. So whatever you get here, number of moles of calcium carbonate are going to be half of this quantity. So 0.75 into 25 upon 2 into 1000 will be number of moles of calcium carbonate. So depending upon the answer is asked in mass or moles, you can use any of these methods. Fine. Now moving on to the next, calculate molarity of a solution of ethanol in water in which the mole fraction of ethanol is 0.04. Clear? Now here I am giving you two methods. One, a very simple method of understanding this question. Very simple method, children. The number of moles can be considered here, number of moles of ethanol can be considered to be equal to the mole fraction of ethanol, and number of moles of water can be 1 minus 0.04. Why? If I assume the mole fraction to be equal to number of moles of that component, is it justified? Yes, let us see. If I assume the number of moles of ethanol is 0.04 and number of moles of water is 0.96, why? Because if chi ethanol is 0.04, then chi solvent, that is water, has to be 1 minus 0.04. Why? Because sum total of mole fractions of the various components is always equal to 1. So I am assuming the number of moles to be equal to the mole fraction. And if I just cross check this, if I want to calculate the mole fraction of ethanol from this information, number of moles of ethanol upon number of moles of ethanol plus number of moles of water. I still get it this. Yeah, so I can very well assume the mole fraction to be equal to number of moles. Clear? Okay, once I do this, now I can calculate weight of water from the number of moles into 18, the molecular mass, because we've done in one of the previous revision videos, number of moles is given weight upon gram molecular weight. I want weight. So it's going to be number of moles into gram molecular mass, number of moles into gram molecular mass. I get it to be 17.28 gram. Clear? Now, as density of water is approximately 1 gram per cc, that means volume of water will be 17.28 ml. 1 gram water has a volume of 1 cc, so 17.28 gram will have a volume of 17.28 ml. So our job is done till here. Now we want to calculate molarity. So we have moles of ethanol upon volume of solution in ml into 1000. And we get this as answer. This is an alternative method to do the same question. How are we going to proceed with this? Now, I just take chi ethanol is equal to number of moles of ethanol upon number of moles of ethanol plus n moles of water. So this is 0.04. This is given to us. Chi ethanol is 0.04 is given to us, and aim for us is to find number of moles of ethanol in 1 liter of solution. And 1 liter of solution is approximately 1 liter of water. Why? Because the solution is dilute. Even in the previous method, I took the denominator as VML 17 point whatever value we got. ml, this was the volume of solvent actually, volume of water we calculated. This was volume of water. And we substituted it as volume of solution. Why? Because the solution was dilute. The solution contained only 0.04 moles of ethanol. So volume of water plus volume of ethanol is going to be approximately same as volume of solution. That is why we took the denominator as volume of water. Here also we are going to do the same thing. We are assuming 1 liter of solution to be the same as 1 liter of water because the solution is dilute. And since the density of water is 1 liter of water is also equal to 1000 ml of water. And 1000 ml of water means 1000 grams, since density is 1 gram per ml. So 1000 gram is divided by the molecular mass 18 grams, we get these many moles of water. I repeat, this is the mole fraction given to us. Our requirement is to reach to molarity, which means number of moles per liter of solution is what we want to calculate. If we assume the total volume of the solution to be 1 liter, and since the solution is dilute, this 1 liter will also be the volume of water. And since the density of water is 1 gram per cc, so it means 1 liter, that is 1000 ml of water, is going to weigh, right? So we are going to convert this mass of water, which is also the mass of solution, since the solution is dilute, to moles by dividing by molecular mass of water. We get 55.5. And now in this expression, I'm going to put number of moles of ethanol, which is unknown, plus 55.5 is the moles of water, and this is equal to this mole fraction. So solving this, we are going to calculate number of moles of ethanol, and these number of moles of ethanol are present in 1 liter of water or 1 liter of solution, since the solution is dilute. So we would say molarity is 2.31 molar. So I gave you two methods. The first one is an easier method, but whichever you find is comfortable for you, you can go with that. Right? Okay. So the next is molarity of a 0.98% weight by volume solution is asked. So how are we going to proceed? We did a similar question just now in the beginning where I gave you formulas for molarity. So what are we going to do? 0.98% weight by volume solution simply means 0.98 present in 100 ml solution. So what are we going to do? Simply divide the weight of solute upon molecular mass into VML and 1000, and we solve it to get our answer, 0.1 molar. We move on to molality. Molarity is defined as the number of moles of solute present in 1 kg of solvent. So very important to understand, molarity was number of moles of solute in 1 liter of solution. But molality is 1 kg of solvent. It is denoted by small m, and by formula its number of moles of solute upon mass of solvent in kg. So the formula goes like this. Okay, so how does the formula go? Weight upon gram molecular weight. This is going to give us number of moles of solute. This is mass of solvent in gram, and we multiply it with 1000. In case we are substituting mass of solvent in kg, then there's no 1000 in the numerator. This is molality. The most important thing to keep in mind is denominator is mass of solvent and not solution. Next type of question, what is molality of a solution containing 60 gram of glucose and 100 ml water? Molality is asked and volume of water is given. So what is molality going to be? It's simply going to be given mass upon molecular mass. That means number of moles divided by 100 gram upon 1000. So what are we doing basically? 60 given mass upon, this is going to give us moles of glucose. Here we are given 100 ml of water, and since the density of water is 100 ml also means 100 gram. Since we are substituting weight of solvent in gram, we have to multiply it with 1000. So solving this, we'll be getting 3.3 molar. The next is find. You have to just be careful about what is given, whether percentage is given as weight by volume. So it's just about being very clear about masses and volumes. Find molarity and molality of a 15% solution of sulfuric acid. Now, please understand, if nothing is mentioned with percentage, we assume it to be percent weight by weight. If nothing is mentioned, then a given percentage is assumed to be mass percentage, that is weight by weight percent. So, how are we going to proceed with this? 15% solution of sulfuric acid means 15 gram of sulfuric acid is present in 100 gram of solution. And if I subtract the two, I understand that mass of solvent will be equal to 85 gram. 100 minus 15 is 85 gram. And then density of solution is given to us. So if molarity is to be calculated, 15 upon 98 will be moles, and volume of solution we will calculate by taking mass of solution and dividing it by density. This is going to be volume of solution. So what is molarity? Number of moles divided by volume of solution in liter. And we get this as molarity. Or I could have done number of moles upon volume in cc. Cc is the same thing as ml in 2000. Okay, the same answer, 1.56 molar. Clear? Now, to calculate molality of the same solution, okay, I'm using here the overall formula also, XD 10 upon molecular weight that we did in the beginning. So here mass percentage is 15%, density is 1.02, and I'm putting 10 upon 98. I directly get the answer. The first explanation was descriptive through understanding, and this is the shortcut formula. Now, how to calculate molality? To calculate molality, we need to know the mass of solvent. So everything is the same. These are the number of moles as calculated earlier divided by mass of solvent in kg. So we get these many molal, or 0.153 moles divided by 85 gram, and I put here 1000. I get it as 1.8 molar. Right? Okay. So molality of a 10% weight by weight sodium hydroxide solution. This is very simple. 10% weight by weight. What does this description mean? 10% weight by weight simply means 10 gram sodium hydroxide in 100 gram solution, which means 90 gram solvent, that is water, if it's an aqueous solution. So 10 upon 40, given mass upon molecular mass. Weight of solvent in gram and 1000. 2.77 molar will be the answer. Quick revision helps you, children. So please keep revising. And thank you for listening till the end. Like, share, and subscribe with others so that more children get benefited. And do leave your comments and suggestions about what else you think can help you for your exams. Thank you. Have a great day. Happy learning. God bless you all.